This is Module 9 entitled FHRP Concepts, First Hop Redundancy Routing Protocol Concepts. In this module, we'll explain the purpose and operation of a first hop redundancy protocol. We'll explain how HSRP operates. First hop redundancy protocol. It's very important that in a given network that we observe redundancy. Now, this is one characteristics that we need to observe in a network infrastructure. Example, like in this case, instead of only having one router, we need to, let's say, provide another one, backup, sort of, that in case, let's say, R1 fails, there's another router, or like in this case, a layer 3 switch that will take place. So that's actually, so let's say if you have this setup, it will not work automatically that say when R1 fails, automatically all computers or end devices will connect to R2. For that to happen, we need to set up these redundancy routing protocols. Okay, so that's the use of the redundancy routing protocols. So again, end devices are typically configured with a single default gateway, IPv4. So if the default gateway router interface fails, LAN hosts lose outside LAN connectivity. And this occurs even if redundant router or layer 3 switch that could serve as a default gateway exists. So first hop redundancy protocols are mechanisms that provide alternate default gateways in a switch network where two or more routers are connected to the same VLANs. So again, in this redundancy routing protocol, we provide router redundancy. This is a way to prevent single point of failure at the default gateway, and that is a way for this to work is to implement this virtual router. Actually, the way I see this virtual router is like the virtual IP add, where we need to set it on the, or say on the two routers. So from your primary to the backup router, and also this will serve as your default gateway. So in a way, like computers will connect to the virtual router, and this virtual router is set up on both routers. So in case one fails, the end device is be able to see the backup router. That's how it works. So so again, with multiple routers, we configured this shared IP, sort of a shared IP. And this will act as a single virtual router. This is set up to the two or more routers. So the IP version 4 of the virtual router is configured as the default gateway. And so when frames are sent from host devices to the default gateway, the hosts use ARP to resolve the MAC address associated with the IPv4 address of the default gateway. And the ARP resolution of the MAC, the ARP resolution returns the MAC address of the virtual router. Frames that are sent to the MAC address of the virtual router can then physically processed by the currently active router within the virtual router group. So a protocol is used to identify two or more routers as the devices that are responsible for processing frames that are sent to the MAC or IP address of a single virtual router. Host devices send traffic to the address of the virtual router, and the physical router that forwards this traffic is transparent to the host devices. So redundancy protocol provides the mechanism for determining which router should take the active role in forwarding traffic. It also determines when the forwarding role must be taken over by a standby router. And the transition from one forwarding to another is transparent to the end devices. So the ability of the network to dynamically recover from the failure of a device acting as a default gateway is known as the first hop redundancy. So again, this virtual router, this is again it's not actually a physical router, so it's a virtual IP where you need to set up to this router, and also to this router, and also to be set up as a default gateway. That's how it is. So the moment you set this up, so the standby router stops seeing hello messages from the forwarding, and this is the signal where the standby router will assume the role of the forwarding router. And because the new forwarding router now assumes both the IPv4 and MAC address of the virtual router, those devices see no disruption in the service. There are different redundancy routing protocol out there. I'll provide a video demonstration for the HSRP. Okay, so I'll cover how to configure this HSRP. This is a Cisco proprietary redundancy routing protocol, which provides a transparent failover of the first hop IPv4 address. There's also a redundancy routing protocol for IPv6. Another popular redundancy routing protocol is the VRRP, Virtual Router Redundancy Protocol. This is non-proprietary, meaning even other vendors, not Cisco, has this. Uh, and then also we have GLBP. This is a Cisco proprietary and protects data traffic from failed over router or circuit. Good thing with this one is that allowed load balancing. It's like, let's say you have two routers, both of them are used. In HSRP, there's like one router that's declared primary, and the other router will only work the moment that the primary router fails. In GLBP, both of them are working. Both of the two routers um, are accepting data, accepting packets, forwarding, let's say, to an outside network. There's also a GLBP for IPv6. Another one is ICMP Router Discovery Protocol. This is legacy, okay, meaning old one, and it allows IPv4 hosts to locate routers that provide IPv4 connectivity to other IP networks. In HSRP, Hot Standby Router Redundancy Protocol. So again, this is Cisco proprietary. There's also for IPv6. It has a way to avoid losing outside network access if your default router fails. It is designed to allow for transparent failover of a first hop IP device. It ensures high network availability by providing first hop routing redundancy for IP hosts. HSRP is used in a group of routers for selecting an active and a standby device. And in a group of device interface, the active device is the device that is used for routing packets, while the standby is the device that takes over when the active device fails. So the function of the HSRP is to monitor the status of the HSRP group. So again, we choose one router that will serve as the active. So all computers initially will connect to the active router. The other router will be declared as a standby. A way to identify who will be the active is with the priority. So the one that has the higher priority will become the active router. By default, the priority HSRP priority number is set to 100. So for a router to be active, you need to increase the priority number to 100. And by default, after a router becomes the active router, it will remain the active router even if another router comes online. So to force a new HSRP election process to take place, when a higher priority router comes online, preemption must be enabled using this command, standby preempt. So preemption is the ability of the HSRP to trigger the re-election process. And preemption only allows a router to become the active router if it has a higher priority. These are the different states that the HSRP has. First, it goes into the initial state, where in this state, this state is entered through a configuration change or when an interface first becomes available. Then it goes into the learn. The router has not determined yet the virtual IP. Then the listen, this is where the router knows the virtual IP. In the speak, the router sends periodic hello messages and participates in the election of the active and the standby. And then with the standby, the router is a candidate to become the next active router and sends periodic hello messages. As a summary, again, FHRP provides an alternate default gateway in switch networks where two or more routers are connected to the same VLAN. One way to prevent a single point of failure at the default gateway is to implement a virtual router. With a virtual router, multiple routers are configured to work together to present the illusion of a single router to the host on the LAN. When the active router fails, the redundancy protocol transitions the standby router to the new active router role. The standby router again stops seeing hello messages from the forwarding. The standby router assumes the role of the forwarding router. And because the new forwarding router assumes both the IPv4 and MAC of the virtual, the host devices see no disruption in service. These are the different options, available options for FHRP. We have HSRP, we have VRRP, and GLBP, and IRDP. HSRP Cisco proprietary. It allows for transparent failover of a first hop IP device. In a group of device interfaces, the active device is the device that is used for routing packets, and the standby device is a device that takes over when the active device fails. The router with the highest HSRP priority will become the active router, and preemption is the ability of an HSRP router to trigger the re-election process. And this ends this chapter. Uh, I'd like to thank you for listening and keep safe, and together we learn as one.